Hello students, welcome to the lecture. Today's topic is maximum speed for a vehicle moving on a horizontal circular road. On the left hand side, we have a diagram of a vehicle which is shown moving on a circular road whose radius is r. On the right hand side, we have a free body diagram of the vehicle which depicts all the forces acting on the vehicle when it is moving on the circular road. So let us see the forces that are acting. So we have a static friction force which is acting towards the left. Then we have normal reaction, and then we have weight, that is mg. R is nothing but the radius of the circular track. So we have some notations to go further with the derivation. M is nothing but the mass of the vehicle, R is the radius of the vehicle, and Fs is the static friction which is acting between the road and the tires. So what does the static friction do? So basically it provides the necessary centripetal force which is required for the circular motion, and it also prevents the object or the vehicle from outward slipping. So when you must have traveled through mountainous terrain, you must have realized that when we turn towards left, there is a tendency of us getting thrown outwards, right? So same thing happens over here. The car is being thrown out of the circular track, and to avoid this outward slipping, the static friction is acting on the vehicle. Let's start with the derivation. So we have the FBD on the left hand side. We know that the normal reaction in this FBD is balancing mg because there is no vertical movement. So we can write down n is equal to mg. And as we discussed just a few seconds ago, that there is a centripetal force acting on the vehicle because it is moving on a circular track, and that circular force is provided by nothing but our static friction. There is another way to look at this static friction from the frame of reference of the vehicle. So if we go into the frame of reference of the vehicle, that is, we become an observer and sit onto this vehicle, then it is an accelerated frame of reference and there should be a pseudo force. The pseudo force in circular motion, we all know, is nothing but the centrifugal force. And this outward centrifugal force is balanced by the static friction. But in which frame of reference? In the frame of reference of the accelerated circularly moving vehicle. So we can write down Fs is equal to mv square by r. This mv square by r is nothing but the centrifugal force, but it will only come into the picture when the observer is in the frame of reference of the vehicle. Now, we know that the radius, mass, gravitational acceleration, n, all these are constants. Therefore, if we want maximum velocity, then the static friction force must be maximum, and the maximum value of that static friction, we all know, is nothing but the limiting value, which is given by mu s into n. Over here, mu s is nothing but coefficient of friction. Now, let us use the equations and try to get the answer. So we have n is equal to mg, and we have Fs is equal to mv square by r. Let's divide these two equations. We get Fs upon m, n is equal to mv square upon r upon mg. M and m gets cancelled, and what we get is v square by rg. Now we just saw that for velocity to be maximum, that is for maximum velocity, we require friction force to be maximum, which is nothing but mu s into n. So let's substitute these values and let's find out the maximum speed of the vehicle. So we have the equation Fs is equal to v square by rg, and the maximum velocity can be calculated by substituting the maximum value of friction, which is nothing but mu s into n. So substituting the values, mu s into n, just a minute, I just forgot an n over here. Yeah, Fs upon n is equal to v square by rg. So substituting the values, we get mu s n upon n is equal to v square by v max square by rg. n and n gets cancelled. So from this we have Vmax square is equal to Vmax square is equal to mu s rg, and finally we get the maximum velocity under root mu s rg. So whenever we have a vehicle moving on the horizontal circular road, the maximum velocity for that vehicle is nothing but under root mu s rg, where mu s is the coefficient of static friction, r is the radius of the circular path, and g is nothing but gravitational acceleration.